How does this scanner work? Moreover, who invented it?
Since the Second World War, the image of the heroic inventor has tended to dwindle. And if you point at any of our more recent inventions, you're much less likely to have the public say, oh yes, the laser, that was invented by A.
The first laser was built at the height of the Cold War. When its awesome potential became clear, research was immediately classified. The basic design is still the same today. Lasers exploit the property of some materials to produce an extremely pure form of light. The heart of the first laser was a single crystal of pure ruby. At each end, a mirror ground almost to perfection. Hit with intense light from a powerful flash lamp, the ruby becomes pumped up with energy. Deep inside, one atom releases its energy as a pulse of very pure light. That triggers others to do the same, so the pulse gets stronger and stronger as it bounces between the mirrors. One mirror is made deliberately imperfect, so part of the pulse leaks out each time until the energy in the rod is drained. Today, not all lasers use a solid ruby crystal. This supermarket scanner uses a laser. Like the disposable diaper, it's a typical modern technology in having no one inventor. It's a combination of many technologies. Each product in the supermarket is given a unique number. The number is represented as a barcode, a series of thick and thin printed bars. Inside the scanner, a laser shines a beam of light into a system of mirrors. One of the mirrors spins round on a motor, so the laser beam comes out sweeping along a pattern of lines. There is only one beam, but it sweeps so fast that our eyes see the complete pattern. If the beam crosses a barcode, it's reflected back where the pattern is light and absorbed where the pattern is dark. So the reflected beam flashes on and off, like Morse code. The long and short flashes are picked up by a light sensor and decoded by electronics to give the product number. In turn, that lets a computer in the register identify the product and charge for it. Compact discs work in a very similar way. A CD is mostly plastic. The plastic protects a thin aluminum disc covered in a pattern much like a barcode, except the bars are just 1/1000th of a millimeter wide. The CD player uses a laser to read the tiny pattern on the disc. Its beam is infrared, so it's not visible to our eyes. Like the bars on a barcode, the pits on a CD represent numbers. The numbers stand for the vibrations of a sound wave.
If you had set out in the late 1950s to invent a better way of storing music or to move people through supermarket checkouts faster, I don't believe for a minute you would have invented the laser. Once you've got a laser, what happens with it depends very much on the environment. And when the laser was invented, what drove the applications at first was the perception of military use, the death ray, the James Bond image, which nearly everybody is familiar with.
There's a very old image of the ray. There's this magical ray. We see it in old paintings and drawings and so forth, whether it's radiating out as a halo or the evil eye. And this has carried forward right into modern times. There were dozens and dozens of films featuring magical rays and death rays.
Gunfire! Save yourself, Flash! You'll be burned to a cinder! I'm setting you free first! He has chosen his own death!
They're often called death rays, but they also can do all sorts of wonderful transformations. We find them altering living creatures, making them larger, making them smaller. We find them healing. There are healing rays and these things, but most commonly they're the death ray, which is used to destroy cities or wipe things out and so forth. All of these things get mixed together until it becomes very hard to disentangle and say, wait a minute, somewhere in here there's a little laser that's used for communication or something and not used to irradiate females or to blow up cities or transform living flesh into monsters and so on.
Powerful military laser systems do exist. Yet the destructive power of a laser has never yet been used directly in a real war.
There were a number of practical problems that really meant that this sort of death ray concept has not come to any reality. But what does work is using it as a way to mark targets. You shine a relatively low-powered laser from one aircraft onto the target, you illuminate the target with the laser, and the smart bombs, which we all saw used in the Gulf very effectively, have a sensor in the nose of the bomb which picks up that illuminating spot and flies the bomb deliberately to the marked target. So instead of being the means of producing the destruction directly, the laser guides the destruction to the target, not the idea that was originally envisaged.
There's a famous film, not famous at the time, but since became famous because the star was Ronald Reagan, in which death ray is used to shoot down airplanes, which the bomber airplanes were the great fear of the 1930s, and justly so. And so a ray would be a good ray if it could destroy attacking bomber airplanes.
50 years later, Reagan was playing a new role, a president promoting the Strategic Defense Initiative.
Let me share with you a vision of the future which offers hope. I call upon the scientific community in our country, those who gave us nuclear weapons, to turn their great talents now to the cause of mankind and world peace, to give us the means of rendering these nuclear weapons impotent and obsolete.
Enormous quantities, billions and billions of dollars have been spent by the military on secret programs trying to use the laser as a death ray, trying to use them to burn up tanks and so forth. Unfortunately, it's just been money right down a rat hole.
The laser is like many technologies. Its applications proved unpredictable. Today, it's no longer seen as a highly specialized death ray. Instead, a laser is just another standard component available off the shelf. Lasers are built from parts exploiting many other inventions, and a laser needs many more inventions around it to be useful. Virtually every application of laser technology puts the laser inside a much larger system. Marking surfaces is one of the most common applications in industry. The world market for laser products is now worth over $100 billion a year. Many laser systems do use the focused power of laser light to cut, burn, and weld. But the overwhelming majority are found in applications that have very little to do with death rays. Perhaps it is because the laser still seems new that an aura of mystique persists around laser technology. In many ways, the laser is a model technology, a power that can be used for good or for evil. Our culture is still coming to terms with technology. We no longer charge the earth with mystical power. Instead, we have built new myths around technology and the process that shapes it.
The question is, how do you come out of this? You don't come out of this with a nice, simple 2-cent answer you can give to the person on the street. But clearly, if you're talking about how does something like the telephone get invented, there's certainly going to be market forces, there's certainly going to be social forces, there's certainly going to be brilliant and almost heroic individuals involved. No one of these myths stands alone, but each contains a partial truth. And taken singly, any one of them as a total explanation doesn't work.
Somehow we imagine these two separate spheres, nature and technology, and yet really they are not so different as they seem, because technology is absolutely a human activity. It's as natural for human beings to have technology as it is for birds to make nests or for fish to swim. Before we were human, we had technology, and we became human through technology.
If we understand a process, then we can begin to monitor it, reflect on it, and change it. If we don't understand the process of technological change, in a sense, we're always going to be victims of something we're doing ourselves. That's the interesting paradox. We're doing it at the same time we're victims of it.
It seems like it's inherent in technology that once you reach a certain point, once you start communicating and putting things together, technology is going to take off like this. It's somehow in the nature of knowledge that when it reaches a certain point, it will begin to feed on itself and take off. And that's where we are now.